Hello everyone, I'm Dr. Cong. This class, we are going to talk about host immune response to parasites. First, let's talk about the parasite antigens. Parasite antigens are very complex. Parasite antigens can be classified into body antigens, surface membrane antigens, ootypes, and excretion-secreting antigens. It can be classified into different stage antigens according to the development stage. It can also be classified into protein, polysaccharide, glycoprotein, glycolipid antigen, etc. It can also be classified into diagnostic antigen, protective antigen, pathogenic antigen, and so on. Once the parasite enters the host, the body will have a defense response with innate immunity and adaptive immunity to resist the parasites. Let's see the innate immunity. The innate immunity against the parasites is a resistance that is pre-existing and is not acquired through contact with antigens. It is non-specific and includes barriers to infections as skin and mucous membrane, macrophages, inflammatory mediators, and complement. The innate immune mechanism mediated by toll-like receptor has been well understood. Innate immune cells of the body can express a variety of toll-like receptors, can recognize the nucleic acid, protein, sugar, lipid, and other molecules of the parasites. Third, the adaptive immunity. The specific immune response of host humoral immunity and cellular immunity in the resistance to parasitic infection play a key role. Antibodies can be alone or with the antigen, the complement or antibodies dissolve or kill parasites. ADCC common have antibody-dependent cell-mediated cytotoxicity immune effects. ADCC is an important mechanism of host in blood vessels or the lymphatic system to kill the parasites. The cellular immunity also plays an important role in anti-parasitic infection. Antigen-activated T cells secrete interferon gamma and TNF-beta, and activated macrophages to secrete nitric oxide, playing an important role. Just like immune response to herpes, worms such as filaria, ascarias, and schistosomes induces high levels of specific IgE antibodies and eosinophils. This characteristic response pattern is to stimulate the Th2 subset of CD4 cells, which secretes the cytotoxin of IL-4 and IL-5. The immune response to protozoa. Different protozoal infections induce different humoral and all cellular immune response. Cellular immunity plays a more important role in protozoa. For example, Entamoeba histolytica. The first T cells are involved in three aspects. One is directly dissolving amoeba and contact dependence. The second, produce cytotoxins and activate macrophages to resist amoeba. The third is helper B cells produce antibodies. The second aspect is about the macrophages-mediated anti-amoeba and activity is a basic model of host antimicrobial infection. The interferon gamma plays a major role in the anti-amoeba effect. So, the host adaptive immunity to parasitic infection can be divided into sterilizing immunity and non-sterilizing immunity. So, sterilizing immunity is after the parasitic infects the host. The host can eliminate all the parasites in the body and has complete resistance to reinfection with the same parasites. For example, cutaneous leishmaniasis caused by leishmania, which produces a strong adaptive immune response that completely clears the parasite and develops a durable and stable resistance to reinfection. This is a very rare form of immune response in parasitic infection. The non-sterilizing immunity. The most common immune response is non-sterilizing immunity. The specific immunity induced by most protozoal infections cannot clear the existing parasites in the body, but it helps to reduce parasite load and has a certain resistance to reinfection, such as Plasmodium, Toxoplasma gondii, and trypanosomes. This is a very common form of immune response in parasite infection. When the host immune response disappears, parasite can infect human again. This type also includes premonition and concomitant immunity. So what is premonition? So certain parasitic infections, such as Plasmodium falciparum, Toxoplasma gondii, American trypanosomes, induce specific immune response can make the parasites in a state of low load. Low proliferation lead to clinical recovery without obvious symptoms, which produce specific attack resistance ability. This immune phenomenon called premonition. So what is concomitant immunity? Some parasites, such as Schistosoma japonicum, are induced by infection, and the host is unable to kill and clear the parasites completely, but they have the ability to resist the reinfection of the same parasite larva. This immune phenomenon is called concomitant immunity. Okay, this class we know what immunity induced by parasites. Next class, we are going to talk about the immune evasion of the parasites. Thank you. See you.